On May 24th, 2016, a classic high plane setup produced the Dodge City Tornado Fest near Dodge City, Kansas, where a cyclic supercell along a dryline outflow boundary intersection produced roughly 13 tornadoes from a single storm. I'm Gabriel Harber, and you are listening to the Storm Chaser Coaching Podcast. I'm here with lead coach Trey Greenwood, and we are going to give you an in-depth analysis from a storm chasing perspective on what exactly happened with the Dodge City, Kansas Tornado Fest, as Trey likes to call it. Trey, how you doing today, man?
Doing well. I'm excited for this one because this is one of my better chases I've had in my chasing career. So this will be a fun one to go over.
Yep, and you never let me forget about it. We actually have a running joke over in our Discord server when we're doing live streaming, a little custom command that we can pop up in the chat because you do mention the Dodge City event so often.
It's for good reason, I think, because it's a lot of people's career chase day. 13 tornadoes from one storm. All of them were photogenic. You had multiple in progress at once. It was everything you'd want in a tornado setup, mostly in the middle of nowhere, too. So it was really the perfect storm chasing setup.
Indeed. And before we get started, I want to remind everyone that this is actually sourced from an episode from your Convective Chronicles YouTube channel. You did an in-depth breakdown of this, and they can find that link in the description below. So if after listening to this podcast, you want to go and check out some analysis that's a little more in-depth, that has some visuals, things like that, highly recommend you check out Trey's YouTube channel if you're living under a rock and somehow have not been visiting it regularly over the last few years. But with that said, let's go ahead and get started with the first question I have for you, Trey. Can you explain how the outflow boundary from the northern Kansas MCS became the key focus for tornadoes near Dodge City?
Yeah, so that day we had a pretty typical air mass for spring over the area. Moist air mass ahead of a dry line that was situated across the central and southern high plains. But the kicker here was that morning MCS across Kansas. We had that MCS roll through, move into kind of northern Oklahoma as well. But the key there is what it dissipated with time. A lot of times you'll see these MCSs just persist for quite a while. That means that there's just a continued production of cold air that's pushing that outflow, and the outflow will just continue to surge and not really be stationary. And you want a stationary outflow boundary for the best chance for storms to latch onto it and produce tornadoes. And that was the case here. The MCS moved off into northern Oklahoma, dissipated, and behind it, you just were left with the wind shift along that outflow boundary. And also here, a key was that it was able to destabilize on both sides. So if you see an outflow boundary with a lot of cloud cover on one side, on the cool side, and sunshine on the other, that's going to really increase that temperature gradient. And those really sharp boundaries are not quite as favorable for storms to latch onto. This one, though, was a perfect boundary. It was baking on both sides, as we like to say, surface heating on both sides, so that temperature gradient really washed out, and you're just left with that wind shift and the enhanced low-level shear along that. And the boundary was, in essence, stationary, and that allowed the storms to really latch onto it and go nuts.
Go nuts indeed. And if you listening right now want to go nuts yourself in terms of researching this event, we actually put together all of the podcast notes that we use to derive the outline structure for the episode. You can find a link to that in the description. It'll take you to a form. You fill out your information, and we will email you those podcast notes. I think it's 6, 7, maybe 8 pages. So definitely the kind of thing that you'll want to grab for yourself if you are big into researching these types of events. Trey, next question I have for you is, what made that dryline outflow boundary intersection south of Dodge City such a high confidence target compared to Scott City or the Colorado storms?
Yeah, so these dry line outflow boundary intersections are really the optimal target in these cases because on a typical dry line, you can get really robust supercells. A lot of times, though, you need some extra help for the environment to be favorable for tornadic supercells. And that was the case here with the outflow boundary intersecting that dry line. So when you have an outflow boundary that's intersecting a dry line, at that intersection point is a lot stronger surface convergence, so you have a better chance of actually initiating storms. But also when storms initiate there, they're able to track along the outflow boundary and tap into that increased spin and low-level shear along that boundary and they have a better chance of latching on. And those storms that latch on they have a much better ability to become robust tornado producers. There was that secondary target in Colorado. So Northeast Colorado, you have a lot of the influence of terrain up there. So that was certainly a viable target. And then the Scott City storm, so western Kansas, north of the Dodge City, Garden City area, just along the Dryline. There were some tornadic storms up there, but you didn't have the influence of the outflow boundary. So the background environment was somewhat favorable for tornadic supercells, but it was going to be always maximized where that outflow boundary was and where it intersected the dry line. Because again, you had a better chance of initiating storms and those storms to track along the boundary, which is exactly what the Dodge City supercell did.
Now, looking at soundings, how did the combination of extreme CAPE, particularly strong low-level CAPE, and curved hodographs translate into such efficient tornadogenesis?
So in these cases with large low-level CAPE, that's really going to make it easier for the supercells to undergo tornadogenesis because you have really strong low-level updrafts. You have a lot of that spin along the boundary, what we call vorticity. And when you have strong low-level instability, that vorticity along the boundary is tilted and stretched into the vertical in underneath updrafts, and the updrafts are ingesting that spin. And as that happens, they can much more easily undergo tornadogenesis. So in this case, you had extreme instability, very strong low-level instability. So the storms that fired along the boundary were just able to tap into that really strong spin in the low levels. And when you have strong low-level shear as well, obviously those large looping hodographs are often considered a prerequisite for tornadic activity. Not always the case, but when you have that in place and strong low-level instability, that's a combination for significant tornadoes, and that's what we got here.
For those of you who are looking to join a group of like-minded storm chasers, as well as talk to some of our coaches, I have the perfect place for you. We have a Discord community. The link is in the description. I think we're like at 1,300, something like that, people in our community right now, which is absolutely mind-blowing. It's just as active as you would imagine, too, with storm chasing season picking up here on the horizon. And we've also got a couple of ebooks for you. Trey did an incredible job creating these absolutely timeless masterpieces. They've got vital information that you need, especially if you are just thinking about getting into storm chasing. There's one that is called the 8 Rules for Storm Chasing Safely. Highly recommend you pick that up. Links for those are in the description as well. Trey, what radar signatures during the event told you this storm was going to be strongly cyclic and not just a one tornado supercell?
First, you could see that the storm was latched onto the outflow boundary. So it developed a lot on the dry line. And then you could see the fine line of the outflow boundary on radar, and it was feeding directly into the hook echo of the storm. So we knew the storm was latched onto the boundary. The boundary was stationary. The storm was latched onto it. And so that usually tells you that you're going to see quite significant tornado production from that storm. And also, once the storm got underway and we started producing tornadoes, you could see the classic evolution of a cyclic supercell where you have the original mesocyclone that will, during the occlusion process, the rear flank downdraft wraps around the tornado, cuts off the warm, moist inflow, and induces dissipation. So when that happens, usually, and in this case, this was a textbook example of that, the old mesocyclone and tornado occludes or deviates to the north or left of its previous track, and a new mesocyclone takes its place. And so we had that happen here multiple times. You could see that after the first cycle of the supercell. And then this was a very unique case in that as this was happening, we had both of those mesocyclones, the old mesocyclone that was occluding and the new mesocyclone, both were producing tornadoes at the same time. That doesn't always happen. Usually the new mesocyclone needs a few minutes to get organized. The old tornado will dissipate and then you get new tornadogenesis. That was not the case here. You had the occluding tornado that remained fairly strong heading off to the north, and then you had your new mesocyclone that was starting to produce other tornadoes at the same time. So were some environmental clues as well, but this was just overall a textbook example of a cyclic supercell.
Now, from a chasing standpoint, how do you safely position around a storm that's producing multiple simultaneous tornadoes and repeated occlusions?
It definitely can be very dangerous. So precautions need to be taken in those cases. And one thing you can do ahead of time when you're forecasting these kinds of events, or really any event for that matter, especially these events with very strong instability, fairly weak flow in the mid and upper levels of the atmosphere, so storm motion is going to be relatively slow. Those are the kinds of environments that favor what we call deviant tornado motion. So this is based on research by Cameron Nixon and others. But this deviant tornado motion is able to tell us how. So we talked about the occlusion and how the old mesocyclone moves to the left or north. Deviant tornado motion and the technique that Cameron uses is able to tell us how far is that tornado going to deviate to the north, so that you can prepare ahead of time. And if you're north of a tornadic circulation on these kinds of days, you need to be very much alert and aware of the deviant tornado motion. So when you're forecasting, you can pull up some forecast soundings from the models and take a look at the hodograph. You want to find the average wind in the lowest 500 meters of the atmosphere. You want to take that, compare it to your storm motion, and then find the midpoint of those 2 points and draw an arrow from the origin of the graph toward that point. And that is your deviant tornado motion vector. And in a lot of these cases, Dodge City included, that deviant tornado motion vector will be well to the left of the actual storm motion vector. And that would tell you that tornadoes may tend to deviate quite a bit to the north as they're dissipating or occluding. So in those cases, you really need to be careful when you're north of a tornadic circulation. And we've seen some incidents where folks have been caught off guard by that. But with that forecasting technique, that can get you safely out of the way of these rapidly occluding mesocyclones. So that would be my main advice. If you want to stay safe in these situations, staying to the east or southeast of the mesocyclone is probably your best bet. But anytime you're north of the mesocyclone and tornado on these kinds of slow-moving storm days, that can get you into some trouble, and you have to be very aware of deviant tornado motion.
Bonus question for you, Trey. I'm going off script here, but with what you just shared, which is absolutely wonderful advice, by the way, it got me thinking, what are some things that I can be looking for if I am out storm chasing and I am north of the storm? I'm aware that I need to be looking for these deviant tornadoes. Is there like a forward motion trick that lets me know, oh, it's time, like I better actually fall back a little bit, or maybe even speed ahead to the east because this one's looking like it's about to become deviant? Is there something we can look for to give us those visual cues?
Probably in that case, it's just the classic situation where if you see the tornado not moving left or right, it's just getting bigger, it's coming right at you. And so in those situations, you need to have your head on a swivel. When you're a few miles east of the storm with a northeastward moving storm, you can not let your guard down, but you can be a little bit more relaxed in those scenarios. Obviously, you always need to have your head on a swivel when storm chasing, but especially if you're north of the tornado. And you'd want to be watching radar very closely. And you can start to see sometimes visually as well when that occlusion process happens. You'll start to see that the tornado and the updrafts before they were co-located, but now they might not be. The tornado may be in one spot, but the actual updraft of the storm may be moving off in the direction it was before, and that may tell you that the tornado is starting to occlude and may start to induce that northward motion. So really, just visually, you need to have your head on an absolute swivel when you're north of a tornado. Be checking radar very often to see, that radar is going to be able to tell you, especially the velocity data and the reflectivity. You'll see the hook start to move off to the north a little bit. The velocity couplet will start to make a northward turn as well. But visually is probably going to be your best bet. Visual cues are going to be your best bet in those scenarios.
Remember to check out those links in the description below, and then watch another video.